Good morning, my dear students of second secondary. Today's lesson is called the circle, and this lesson is the last lesson of math applications. This lesson is given for scientific section only. Let's start. The circle. Firstly, the definition of the circle is the set of points which are at a constant distance from a fixed point in the same plane. The constant point is the center of the circle, and the constant distance is called the radius of the circle. The circle is denoted by its center. First, the equation of the circle in terms of its center, coordinates and its radius. If A is a point on the circle and its coordinates is x, y, the center of the circle is given as M and its coordinates D and E, then the circle equation is x minus d squared plus y minus e squared equals r squared. This is the equation of the circle. And this rule can be proved by using the distance rule, which we have studied before in third prep. The distance between 2 points can be written as the square root of x2 minus x1 squared plus y2 minus y1 squared. This is the distance between 2 points. Remark: if the center is the origin point, then the equation of the circle is written as x squared plus y squared equals r squared. Here, if a point B, x1, y1, and the circle equation C, then x minus d squared plus y minus e squared equals r squared. If x1 minus d squared plus y1 minus e squared equals r squared, then the point B is on the circle. If x1 minus d squared plus y1 minus e squared equals, greater than r squared, then B is outside the circle. Also, if we substituted by the point B, x1, y1, instead of x and y in the equation of the circle, and we get x1 minus d squared plus y1 minus e squared less than r squared, then B is inside the circle. The second part of this lesson is the general form of the equation of the circle. Since the equation of the circle is x minus d squared plus y minus e squared equal r squared, I'll try to simplify this expression. I'll expand each bracket. X squared plus d squared, and their middle term is the first multiplied by second multiplied 2 equals negative 2xd, plus the second bracket y minus e all squared can be expanded in the form y power 2 minus 2ye plus e squared. Then I'll transfer r squared from the right hand side to the left hand side to written as negative r squared equal 0. Let m due, let m the center, de equals negative l and negative k. Then x squared plus 2xl, I'll substitute instead of d by negative l. Instead of d, I write negative L. Also, instead of E, I write negative K. Then x squared plus 2xl, take care, negative 2x multiplied by negative L is positive 2xl. plus d squared is negative L squared, which equals L power 2. Then y power 2 plus 2yk plus k squared minus r squared equals 0. I'll arrange the expression of this equation to be written as x squared plus y squared plus 2xl plus 2yk plus L squared plus k squared minus r squared. Take care. I will write a constant number c instead of L squared plus k squared minus r squared. Take care. C equals L power 2 plus k power 2, which are the coordinates of the center of the circle squared, minus r squared. Then r squared is L squared plus k squared minus c. To get the radius of the circle from the general equation of the circle, I will take the square root of the value of r squared. Then r equals the square root of L power 2 plus k power 2 minus c. Also, to get the center of the circle from the general equation of the circle, you should divide both the coefficient of x and the coefficient of y by negative 2. To get the center of the circle, you should divide both the coefficient of x and y written in the general equation of the circle by negative 2. As we will see this in the following examples. The general equation of the circle, take care, the general equation of the circle is free from the term xy. Also, it's second degree equation, and the coefficient of x squared should be equals the coefficient of y squared equals 1. To find the center and the radius of the circle using the general form, you should put the equation where the coefficient of x squared and y squared equals 1. Here, the special cases of the general equation. If the circle passing through the origin, then c equals 0. Then the equation x squared plus y squared plus 2xl plus 2yk equals 0. Also, the equation of the circle whose center lies on x-axis, the equation is free from the term containing y, where k equals 0. Then x power 2 plus y power 2 plus 2lx plus c equals 0. You know that if the center is on x-axis, if the center is on x-axis, then the y coordinate of the center equals 0. Therefore, k equals 0. And the equation is free from the term containing y. If the center of the circle is on x-axis, here is the two axes x and y, there is a circle, its center is on x-axis, then the coordinates of the center will be negative L and 0. Equation of the circle whose center lies on y-axis. Therefore, L equals 0, and x squared plus y squared plus 2yk plus c equals 0. Take care. The equation number 4, the equation of the circle touches x-axis. Since c equals L squared plus k squared minus r squared, as you see in the figure, if the circle touches x-axis, therefore the radius of the circle will be equals the absolute value of k. Then r equals absolute k, then r squared equals k squared. Therefore, c, which equals L power 2 plus k power 2 minus r power 2, here r equals k, then the value of the constant value c equals L squared. Therefore, x squared plus y squared plus 2lx plus 2ky plus L power 2 equals 0. Here the equation of the circle touches y-axis, since c equals L power 2 plus k power 2 minus r power 2. R squared equals L squared, therefore c equals k power 2. Therefore x power 2 plus y power 2 plus 2lx plus 2ky plus k squared equals 0. Then take care. If the circle touches y-axis, then the value of c equals k squared. If the circle touches x-axis, then the value of c equals L power 2. Number 6, equation of the circle touches the two coordinate axes. If the circle touches x-axis and y-axis, therefore r equals absolute value of L equals absolute value of k. Take care. If the circle touches the two axes x and y, therefore its center lie on the line whose equation y equals x. Then r equals absolute value of L equals absolute value of k. Where c equals L squared equals k squared equals r squared. Then x squared plus y squared plus 2lx plus 2ky plus c equals 0 is the general equation of this circle. Remember that the position of a line with respect to a circle M, let M belongs to the straight line and MC perpendicular to, let M, the center of the circle, C belongs to the straight line and MC perpendicular to this line. If MC less than the radius of the circle, then the straight line L is a secant to the circle. If MC equals R, then L is a tangent to the circle. If MC greater than R, therefore L is outside the circle. Here, there is a circle M. If a straight line L and the C is a point belong to this straight line, I'll draw a perpendicular line segment from M to C. I'll draw a perpendicular line segment from the center M to the straight line to cut the straight line at the point C. If MC is greater than R, then L is outside the circle. Also, if MC equals R, then L is a tangent to the circle at the point C. If MC less than R, then L is a secant to the circle. M and N are two circles of radii R1 and R2. If MN is greater than R1 plus R2, these two circles are called two distant circles. Also, if MN, the line of centers, the line which is joined between the two centers of the two circles, equals R1 plus R2, these two circles are two touching externally circles. If MN is greater than the difference between their radii and less than the sum of their radii, these two circles are two intersecting circles. Here MN equals R1 minus R2. They are touching internally circles. MN less than R1 minus R2. Therefore, one circle inside the other. If MN equals 0, these two circles are called two concentric circles. In the opposite figure, this is circle M, which touches the x-axis and y-axis, which touches both axes, x and y. Take care, the center of the circle lies on the straight line whose equation y equals x. In the previous slide, there is a figure representing a circle touching y-axis. Take care the center of this circle is negative L and negative K, and the radius of the circle equals exactly the absolute value of L. In the previous slide, if there is a figure, this circle in the opposite figure touches x-axis. Take care the center M is negative L and negative K. Take care in this case the radius of the circle equals exactly the absolute value of K. Let's study another slide. Remember that the equation of a straight line passing through a given point x1, y1 and its slope equals m is y minus y1 over x minus x1 equals the given slope m. The length of the perpendicular from the point x1, y1 to a straight line, its equation is ax plus by plus c equals 0 equals the absolute value of ax1 plus by1 plus c over the square root of a power 2 plus b power 2. If the number of sides of a regular polygon equals n sides and the radius of the circle passing through its vertices equals r, then the area of the regular polygon equals n over 2 r squared sine 360 over n. Let's start to solve some examples from the pupil's book. Find the equation of the circle whose center m and radius r, where m equals 2, 3 and r equals 5. It is required here to write an equation of the circle given its center and its radius. It is not required to write a general form of the equation of the circle. Here, the equation of the circle is, remember that, x minus d squared plus y minus e squared equals r squared. Then x minus the center of the circle equals 2 power 2 plus y minus the center, the y coordinate of the center equals 3 all squared. This value equals r power 2. Here the radius equals 5 and the 5 power 2 equals 25. If you try to expand these two brackets and put the expression in the simplest form and transfer 25 to the left hand side to write the whole equation equals 0, then the final result is the general equation of the circle. Another example, m equals 0, negative 1, r equals 2 root 3. Therefore, x minus 0 squared plus y minus negative 1, which is written as y plus 1 all squared, equals the square of the radius r power 2 equals 2 root 3 all power 2, which equals 12. In the opposite figure, here is a point x1, y1 and the straight line ax plus by plus c, and the length of the perpendicular, as we said in the previous slides, the length of the perpendicular equals the absolute value of a. I will substitute by x1 here, ax1 plus b, y1 plus c, all over the square root of a squared plus b squared. Find the coordinates of the center and the radius of the circle of the equation x plus 4 all squared plus y squared equals 9. The center of the circle is negative 4. Take care the equation is x minus d squared plus y minus e squared equals r squared. Here the center of the circle is negative 4 and 0. And the radius of the circle equals the square root of 9. Here the center equals negative 4, 0. And the radius equals the square root 9 equals 3 length units. Write the general form of the equation of a circle whose center M equals negative 2, 3, and its diameter equals 8 length unit. Since the diameter equals 8, therefore the radius equals 8 divided 2 equals 4. And I'll use the equation of the circle, which equals x minus d squared plus y minus e squared equals r squared. Then x minus negative 2, which can be written as x plus 2 squared plus y minus 3 squared equals 4 power 2. Then I expand these two brackets. X squared plus 2 multiply x multiply 2 plus 4x plus 2 power 2, which equals 4, plus y power 2 minus 6y plus 9 minus 16 equals 0. Then x power 2 plus y power 2 plus 4x minus 6y minus 3 equals 0. And this is the general equation of the circle. X power 2 plus y power 2 plus 4x minus 6y, then 4 plus 9 minus 16 equals negative 3. Or I can use the general equation directly. Since M, its coordinates equals negative 2 and 3, then L equals positive 2 and k equals negative 3. Take care, I change the sign of both numbers d and e to write L and k. L equals 2 and k equals negative 3. The radius of this circle equals 4. Then C equals L squared plus k squared minus 4 squared equals 4 plus 9 minus 16 equals negative 3. Then the general equation, x squared plus y squared plus 2lx plus 2ky plus c equals 0. Then x squared plus y squared, here L equals 2, then 2 multiplied by 2 equals positive 4x, then 2 multiplied by negative 3, negative 6y minus 3 equals 0. M 5 and 12, and to pass through the origin. Here the origin point is 0 and 0. The circle passes through the origin, therefore C equals 0. One of the special cases of the circle. Then x squared plus y squared plus 2lx plus 2ky equals 0. L equals negative 5, also k equals negative 12. I'll correct the sign of k equals negative 12. Then x power 2 plus y power 2 and 2lx equals 2 times negative 5 negative 10x plus k equals negative 12. Here 2 times negative 12 equals negative 24. Then here negative 24y and the c equals 0. Therefore the general equation of this circle is x power 2 plus y power 2 minus 10x minus 24y equals 0. The center of the circle is written as 7 and negative 5. Also this circle passes through A, 3 and 2. I'll use the center and the point on the circle to find the radius of the circle using the rule of the distance between 2 points. R equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Then R equals 7 minus 3 all power 2 plus negative 5 minus 2 all power 2. I'll calculate the radius of this circle to be the square root of 65. Since M coordinates are 7 and negative 5, then L equals negative 7 and K equals positive 5. Take care, L equals negative 7 and K equals positive 5. C equals L squared plus K squared minus R squared, negative 7 squared plus 5 squared minus root 65 all raised to power 2. This value equals positive 9. Also, the general equation is written as x power 2 plus y power 2 plus 2lx plus 2ky plus c equals 0. Then x squared plus y squared. Here L equals negative 7. 2 times negative 7 equals negative 14x. And the k here equals 5. Then 2 times 5 equals 10y plus c, which equals 9. The final result, x squared plus y squared minus 14x plus 10y plus 9 equals 0. Another example, given that AB is a diameter in the circle, A equals 6, negative 5, B equals 0 and 2. The center of the circle is x1 plus x2 over 2, y1 plus y2 over 2. Then the center 6 plus 0 divided 2 and the negative 5 plus 2 divided 2. Here the center of the circle is 3 and negative 1. The radius equals square root of x2 minus x1 power 2 plus y2 minus y1 power 2. Here the radius equals the square root of 6 minus 3 squared plus negative 4 plus 1 all squared. Here the center is 3 and negative 1. The radius can be calculated by the distance between 2 points, which is 6 minus, which equals 6 minus 3 all squared plus negative 5 plus 1 all squared. It is not equal negative 4. I'll correct, there is something wrong in this problem. The point A equals 6 and negative 4. Also the point B equals 0 and 2. Get the center, 6 plus 0 divided 2, negative 4 plus 2 divided 2 equals 3 and negative 1. And this is the center of the circle, 3 and the negative 1. Also, to get the radius, I will find the distance between the center M and a point on the circle, which is 6 and the negative 4. Then this radius length equals 6 minus 3 all squared plus negative 4 minus negative 1 all squared. And this value equals and this value equals 3 squared plus 3 squared equals root 18, and root 18 here, and root 18 equals 3 root 2. Then if the center of the circle is 3 and negative 1, then L equals negative 3, also K equals positive 1. I write the general form, x squared plus y squared plus 2lx plus 2ky plus c equals 0. C equals L power 2 plus k power 2 minus r power 2. Here C equals 9 plus 1 minus r squared, which equals 18, and the value of c equals negative 8. The general equation x power 2 plus y power 2, 2 multiplied L multiplied by x equals negative 6x, 2 multiplied by k multiplied by y equals 2y minus 8 equals 0. This is the general equation of this circle. Find the coordinates of the center. Find the radius of the following circles: x power 2 plus y power 2 minus 4x plus 6y minus 12 equals 0. The center equals negative 4 divided by negative 2 and 6 divided by negative 2. Here is the center equals 2 and negative 3. L equals negative 2 and k equals 3. Then C equals negative 12 equals L power 2 plus k power 2 minus R power 2. Then R squared equals L squared plus k squared minus C equals 4 plus 9 minus negative 12, which equals positive 12, and here R squared equals 25. Then R equals the square root of 25 equals 5 length unit. Remember that R equals the square root of L squared plus k squared minus C. X power 2 plus y power 2 minus 8x equals 12. Then x squared plus y squared minus 8x minus 12 equals 0. Here the equation is free from y, then k equals 0. And the center of the circle is negative 8 divided by negative 2 equals 4 and 0. Here L equals negative 4, k equals 0, and c equals negative 12. Then R equals the square root of L power 2 plus k power 2 minus c equals square root of 16 plus 0 minus 12 equals 2 root 7 length unit. Show if the following two circles are congruent or not. Here are the two general equations of two circles. It is required to find if these, to determine if these two circles are congruent or not. To prove that these two circles are congruent, you should get the radius of each circle. In the first equation, the center equals negative 4 divided by negative 2, 8 divided by negative 2 equals 2 and negative 4. Here L equals negative 2 and k equals positive 4. Take care, C here equals 0. R1 equals the square root of L power 2 plus k power 2 minus C equals negative 2 power 2 plus 4 power 2 minus 0 equals 2 root 5. The second equation, it's free from the term of x, then the x coordinates of the center equals 0. 12 divided by negative 2 equals negative 6. Then the center of this circle is 0 and negative 6. Here L equals 0, K equals positive 6, and C equals 16. I'll correct. C equals 16. Then R2 equals the square root of L squared plus K squared minus C equals 0 plus negative 6 power 2 minus 16 equals 2 root 5. Take care. R1 equals 2 root 5. R2 also equals 2 root 5. Therefore, these two circles are congruent. Find the equation of the circle, which is the image of the circle x squared plus y squared minus 12x plus 6y plus 20 by translation x plus 2 and y minus 2. The center of the given equation circle equals 6 and negative 3. Here L equals negative 6 and K equals positive 3 and C equals 20. Therefore, r equals the square root of negative 6 power 2 plus 3 power 2 minus 20 equals 5 length unit. Since the center equals 6 and negative 3, therefore the new center by translation x plus 2 and y minus 2 equals 6 plus 2 equals 8, negative 3 minus 2 equals negative 5, then the new center is 8 and negative 5. Therefore L equals negative 8, K equals positive 5, and R equals the radius of the circle equals 5 length unit. Therefore C equals L power 2 plus K power 2 minus R power 2. Negative 8 squared plus 5 squared minus 5 squared. Here C equals 64. Therefore the general equation of this circle x power 2 plus y power 2 minus 2 times plus 2 times negative 8 times x equals negative 16x plus 2ky 2 times 5 equals 10y plus 64 equals 0. And the equation of the circle equals x minus 8 all squared plus y plus 5 all squared equals 0. Take care. X minus 8, the radius of the circle is 8 and negative 5. Then x minus 8 all squared plus y plus 5 all squared equals r power 2. I'll correct this part equals r power 2, and here the radius of the circle equals 5 length units, yani this part equals 25. Find the equation of the circle which touches the straight line x plus y equals 2 and its center is 3 and 5. Since x plus y equals 2 is a tangent to this circle, therefore x plus y minus 2 equals 0, and the center of the circle 3 and 5. The radius is the perpendicular distance from the center to the straight line. Then r equals absolute value of 3 plus 5 minus 2. I'll substitute by the two values of x and y, 3 and 5, plus negative 2, 3 plus 5 minus 2 over square root of 1 squared plus 1 squared equals 3 root 2 length unit. Here r squared equals 18, and the equation of the circle x minus 3 all squared plus y minus 5, these two numbers are the coordinates of the center, equals r squared, which equals 18. Thank you. Good luck. Thank you.